Lesson 16, using Cramer's rule. Cramer's rule, it's a method for solving a system of linear equations using determinants. It's totally fun. Yes, what's your question?
Kind of off topic, but kind of on topic also. How come it's called Cramer's rule? Is it like talking about Cramer from Seinfeld?
No, it's a different Cramer.
Wait, do you actually know the origins of it?
Of this,
Yes.
Cramer?
Yes.
Yeah, he's a mathematician. No, I don't remember. We should Google it. You can tell us tomorrow.
I'm gonna forget because I have what's off.
Hey, don't you have the computer?
Yeah.
We'll start
Well-
working on homework while you search.
I'm going to explain to you how to come up with Cramer's rule. Yeah, I'm going to derive it for you. Just because it's super fun. Okay, so if you have a set of linear equations, ax plus by equals e, and cx plus dy equals f. This is a system of linear equations. Two equations, two unknowns. And you can actually use Cramer's rule with three equations, three unknowns. But we're just going to do it this way. So multiply the first equation by d, and the second equation by negative b. If I do that, when we add the two equations, your y term will be eliminated. So we're solving by elimination right now. So we have dAx plus bdy equals de. Down here we have negative bcx minus b dy equals negative bf. Now we add the two equations together.
Oh.
So notice that the y's go to 0. And we have dAx minus bcx equals de minus bf. Yes.
How did you get the dAx and then negative dx equations?
I am solving this system by elimination. So
You just use distributive property.
right. Multiplied everything by d. Okay. Now I am going to factor out an x in the left side of our equation. So we have dA minus bc equals de minus bf. Then to solve for x, we divide the two sides by dA minus bc.
Oh. This one's so much easier.
Now what's super awesome is these are determinants of matrices. So I can say that x equals the determinant of, if it's d e b f. So we have ed minus bf. That's a determinant.
What?
What is the
So
wait? Why did you put the e first and the f first?
Because I wanted to show you that oh,
Wouldn't it be the other way around?
no, because we want the answers to our system, so EF to be here, and then here we want the coefficients of Y to find X. So we put BD right there.
Confused. What happened to like
I don't even know what is going on.
Okay?
That's okay, maybe.
Then over down here, we have the determinant of the coefficients of x, y. So we have A, C, B, D, the determinant. So when you do AD or DA minus that multiplied, that's just the determinant of the coefficients of x and y. So to find x, we take the answers, so these two numbers in the first column, and the coefficients of y in the second column. So if I wanted to find y, okay, so to find y, we actually put the coefficients of x in the first column and the answers in the second column, where y would normally go. So we're replacing the coefficients of y with the answers. So we have x, y, put the answers for x, over the determinant of the coefficients of x and y. Might be easier with a real situation.
Yeah, I still have no idea.
This makes sense.
Okay, let me give you an example, okay? Are you ready? Are you ready for this example? Say smile and nod.
No.
Smile and nod. That's how you
Smile and shake.
So 3x plus 2y equals -1, and 4x minus 3y equals 10. So to find x, you're going to do the determinant of the answer, so -1, 10 in the first column, and the coefficients of y in the second column, 2, -3, divided by the determinant that's formed by these coefficients, so 3, 4, 2, -3. To find y, we do the x coefficients in the first column, so 3, 4, and, oops, it's not a fraction, it's a matrix. So 3, 4, and then the answers in the second column.
It's -1. Some of us don't know that time.
So the denominators are always just a determinant of the coefficients. If you think of the first column as x and the second column as y, when you're finding x, you put the second column, the y, but then you put the answers where x go. If you're looking for y, you put the first column for x and the answers where y goes. Then if you do the determinant, x equals, we do 3 minus 20. So -17 over, and this side would be -9 minus 8. -17. So x would be 1.
Wait, why did you use negative?
And y would be, we do 30 minus -4. 30 minus -4. So wouldn't that be 34? And then we have -9 minus, oh, we already know that's -17. So y would be -2. So our solution is 1, -2. Okay?
Maybe
So-
it's one of us did.
Where to place, we're going to, in our practice set,
really makes sense. The negative. I understand the multiplying the matrix.
okay, that's gonna be the end of the lesson for our videotape.